We have an inverting operational amplifier and an input waveform. How do we determine what the output waveform is going to look like? That's coming up right now. Hi, I'm Dr. Bob. There are no lectures here. I just solve problems, homework problems to help you understand how to do them. Electrical engineering at your service. In this problem, we're asked to sketch V out versus T for an ideal operational amplifier in this circuit that's shown below, and given the input wave pattern. So what we're going to do here, first off, we're going to look at some of the things that we have. Let's get over here and get ourselves a pencil to write with. The way we want to do this is get a relationship between V out and V in, something simple that we can use to that will apply quickly and easily. Because we've got a waveform coming in. This waveform VG, which is right here. Let's do this part in yellow. Here is VG over here. That's our input, and this is what our input looks like. This is VG, and as you can see, it starts at 0 volts and goes to plus 0.5 volts after 1 second, and in 2 seconds goes back down to 0, and in 3 seconds goes to minus 0.5 volts, and then at 4 seconds it goes back to 0. So this is typical of a sawtooth waveform that might be introduced into a circuit such as this. Now, the way to solve this is basically using Kirchhoff's current law to, again, the same way we've done in many other problems, look at all the currents going out of a node. And then we're going to choose the node Vn and sum the currents, and they should all add up to 0. And so let's do that real quick. We're going to start out with Vn minus Vg divided by, that's this Vn minus this Vg, divided by 9k ohms, plus the second one is this In that goes into your amplifier, plus Vn minus V out divided by this one, this is Vn minus this V out, divided by 144k ohms. And that all adds up to 0. So what we have, of course, is an inverting amplifier configuration. So what happens is we're going to have some relationship between V out and Vg. And that's what we want to get to. We know that in an ideal operational amplifier, In is equal to 0. It's approximately equal to 0. And Vn is approximately equal to Vp, which is equal to 0. So in a balanced circuit, the Vn is going to be equal to 0. An unbalanced circuit, maybe not so much. And it'll always be a tiny little fraction of a bit off. So once we drop these in, we know this goes to 0, Vn goes to 0, this goes to 0, and what we get is minus Vg over 9k ohms minus V out over 144k ohms equals to 0. And if you solve this, of course, for V out, you get V out is equal to minus 16 Vg. And I'm going to leave that to you to solve. That's a little bit of algebra. Now the next thing is to plot our output. Once we have our function that defines V out with respect to Vg, we can translate between these two waveforms. Here we have the waveform for Vg. It starts at 0, goes to plus 0.5 volts, down to 0, down to minus 0.5 volts, back up to 0. And it's a simple matter of just plugging the numbers into this formula right here. This is the one, let's get a little bit darker here, minus 16 Vg, and the minus there indicates this is an inverting circuit. So whatever you put into it comes out the negative of whatever that is. So in the first case we have a 0. That is our first point at 0. Our second point at 0.5 volts, 0.5 times negative 16 is negative 8. So that's our second point. Our third point is going to be at 0 again. And of course, at negative 0.5 volts, you get 8 volts out. Here's our 8 volts out. And at 4 seconds, we have 0 again. Here's our 0. Now, wondering why you see the 8 volts and the 6 and the minus 8 and the minus 6. And the reason is because the circuit that we have is limited to the supply voltages. So we can't produce 8 volts because our supply voltage is only plus and minus 6 volts. So if we follow this curve, normally this would go all the way down. It would normally go all the way down, but it's not going to go all the way down. It's going to reach across, and then it's going to go back up, and then to here, and of course we're going to stop at the 6 volt. It's going to reach its limit, pass through, and cut across this line, and go back down to 0 volts. And of course this is our solution. So that takes care of this problem. Thanks for watching my program.
If you like my videos, be sure and subscribe to my YouTube channel. And for an organized listing of my YouTube videos, go to my website, www.wherearemyplacebos.com, and click on videos. Have a great day.